And then I'm going to do screen sharing. Okay, so let's get back here. And I think this part we already finished about pandas plot, is it? So with pandas data, you can also do plotting and the bar plotting. So we finished that. And let's see. It's kind of, okay. It's always, okay, and so first, let's take a look at the tips CSV file, and I believe this file is also on our course website. Okay, so this CSV file, we have the column, we have total bill, we also have tip, and we have smoker or non-smoker difference, and we have the day you go to the restaurant and the time, and the size of people in one group go to the restaurant. So that's a general information about this CSV file. And for this CSV file, and today what we are going to first learn is about the cross tab function. For pandas, the cross tab function, what it does is it says it can show frequency, okay, with a certain group. So what this function does is it will do some of the grouping things and show the frequency. So quite useful, okay. So what over here it did is from our tips CSV, from the tips data frame, it's going to pick two columns. The day column, it's about like Monday, Tuesday, Wednesday, the day column, and the tip size. So how many people in one group go to that restaurant? So we're just going to pick those two columns from the data set. And then you apply the cross tab function, okay, to those two column data. And what we get, the output, if you take a look here, you will see the index is regarding day. Okay, Friday, Saturday, Sunday, and Thursday, is it? And the column is regarding the size. So the size is a number of group, number of people in one group at which day go to that restaurant. So the cross tab, because it's not of this data show not originally from the CSV file, is it? So it already did the grouping by the size of the group and also by the day. So that's what the cross tab function does. So it will return you the frequency with whatever the group you wanted to be group. Okay, so that's this part. And then the next part, what we did is we're going to do the normalization for this cross tab, the result. So what we did here first is what we are going to do is to do the summation, okay? And this summation is going to summation the whole row. So it's going to be row by row summation. So row by row summation, then the result is the total counts of the groups for that day. The total, so for each group, the total counts. So that's the summation. And then you are going to use this single individual number. So at Friday, so on Friday with one person in a group to go to that round, and the kind of like the percentage, is it? So then that's why it does the division to do that. So the division, the axis is 0. So that's by column, is it? So that's how this data comes from. And because we can see it's only like, so for one person group and for 6-person group, it's not a lot of numbers showing. So that's why we take them off. We just keep 2, 3, 4, and 5 size group. and that's give us this party percentage, okay? And after that, then we do the data frame plotting, okay, from pandas plot and do the bar plotting. So here is a bar plotting showing the result, and we already learned this before. And so over here, the major thing is a new function called crosstab, okay? And with the crosstab, then you can do certain kind of grouping and calculate, it will automatically calculate the frequency for you, okay? So that's the crosstab. And the second important thing for today's part is the CBOM package. Okay, so CBOM is another very important package. Previously, we learned the PyPlot package for plotting. This is the second quite useful Python plotting. And for this plotting package, what it says is it can make a lot of calculation things and plotting things quite simple. Okay, so and also can make your plotting quite pretty. Okay, so this is a very important plotting package. So I hope in your later exercise you can try to use it. So what here the first thing we are going to do, we are going to calculate the tip percentage. So this is pretty straightforward. So you just use the tip, divide by the total bills minus the tip, okay? So then you get off the tip percentage. And with the tip percentage, then we are going to do the bar plotting, okay? And for the bar plotting, the x-axis is the tip percentage we just calculate. And the y-axis is going to be the day, like Monday, Tuesday, Thursday, something like that. So this is the plotting that we got, okay? And with this plotting, what we need to be careful here is, in our previous bar plotting, we don't have this this single line part, is this, and also from this plotting. What it shows with the tip percentage and the bar, it's a little bit different from what the original data is it? So because the original data, the tip percentage, what it gives is multiple observation for each value in the day, is it? It's multiple. But over here, what we have, the bar shows is the average value of the tip percentage. Okay, so this is, you needed to be careful when you use CBOM, the bar plotting. So if you have multiple observations and what it gives you will going to be the average unless you specify, okay? And also this part I just mentioned, the line part, what it shows is the 95 confidential, the 95 percentage confidence interval. Okay, so that's what that part means. And in our previous, the bar plotting, we don't have that part. Okay, so here to just give you some more information. Okay, so that's regarding the CBOM's first plotting about CBOM bar plotting. And next, let's see. And for the next two plot, we still use pandas data frames plot. So this is the regular pandas plot. This is also regarding the percentage, tip percentage plotting. And this is with the histogram. So we have 50 bins. So we divide the percentage in 50 slots, and then you count how many fall in each slot. And then we have this histogram. So basically this histogram gives us the percentage distribution, is it, for each frequency range. And the next one, this is also regular pandas data frame plotting, and this gives you the density plotting, okay? So this shows the density distribution. So it also shows the tip percentage distribution, okay? So this is a regular one. And with CBOM later on, next we can see with CBOM, the very nice thing for it is it can do very nice histogram and density plotting on a single plot. Okay, so next let's see. So if you take a look, this is CBOM's density distribution plotting. So it has the histogram and the density distribution, both of this plot combined in a single plotting. And here for this example is we first have some random number generated, 200, okay, and with certain mean and the certain standard deviation. And then we are going to, so we have two random group number generated, and then we combine them. And after that, we are going to do CBOM, okay, the distribution plot, use the value. And here specify the bin with 100. And so the result shows it gave you both the histogram distribution and the density distribution. So this is pretty nice, okay. So just be careful here, okay, this is regarding CBOM's distribution plot method. So if you want to do something like this, you can call CBOM's distribute plot. So that's the first CBOM distribution plot. And next is regarding another data set. So this data set, if you see, there are a number of columns, okay, and it's some macroeconomics data. And here, what we are going to use, we are going to use the CPI, so consumer CPI, the M1, the T-buy rate, and the unemployment rate. So we are going to pick those 4 column data and do some plotting, okay? So we read data from the CSV file, and we pick those 4 columns of data, and those 4 column data, the top 5, what we show here, give us some kind of sense, okay? And then next, what we did is we're going to do log of those data. So not the original data, okay? We are going to do log of the data. After that, we are going to do the difference, so calculate the difference between them, okay? So that's, then we're going to drop if there is any null values. So the result of the log and difference shows here, okay? And then we are going to do the CBOM plotting. And here, what we pick is we pick the M1 versus unemployment rate for our CBOM plotting. For this CBOM plotting, the result is going to be a scattered plot and a linear regression line, okay? So this is the CBOM plotting. So CBOM plotting is M1 versus the unemployment with scattered and the linear distribution, okay? So for CBOM, you can also do scatter plotting and linear regression with reg plot. And after class, if you want, you can try more, okay? You can try like M1 versus CPI or employee versus CPI, something like that to see the result. Okay, so this is regarding scattered plotting and the linear regression plotting. And next, what we are going to see quite useful for CBOM plotting is CBOM can also do pair plot. Okay, quite useful. And the first one for the pair plot, the example is pair plotting, because here we pick 4 columns, is it? We have CPI. And we have M1. And we also have the T-buy rate, and we have the unemployment rate. So we have this 4 column of data, is it? And so if we take a look the result, if we take a look at the result, we will see totally we have 16 plot, is it? We have 4 rows. 4 rows of data, and we have 4 rows of plot, and we also have 4 columns of plot, is it? So from the plot, we can see, like if you pick this specific one, then it shows M1 versus the unemployment. Is it? And this whole row, the y-axis is about unemployment, but the x-axis is changing. It's CPI or M1 or unemployment. Is it? And the diagonal one, if we take a look at this whole plotting, the diagonal one is about the distribution of this specific feature. Is it? So this is CPI distribution, and this is M1 distribution. And for all of the other, it's scattered plotting. Is it? So that's what this pair plot does. So it gives you, so if you have a number of features and you want to take a look the relationship among them to get some sense, because later on when we do analysis, this is going to serve some purpose. And then you can pick this pair plotting, okay? And for this one, to specify, okay, the diagonal one, what you want to pick. In this case, it says it's going to pick the KDE. So the KDE is for the kernel density distribution. So for diagonal one, for this case, it pick the kernel density distribution. Okay, and for this alpha, we already learned before, it's about the transparency, okay, the channel. So anyway, so over here we see the pair plotting. It's going to be quite useful, and there are some other options that you can do. And I also have a link for self-learning about the pair plotting. So if you're interested, after class, you can go to that website to see more examples about the C-bound, the pair plotting. And what next, what we are going to see is with C-bound, you can also do some grouping data with multiple plots. Okay, so this is also quite interesting. First, let's take a look at the result. Over here, we have two plots. Okay, we have two plots, not a single one. For these two plots, kind of you have the comparison, is it? You have non-smoker one and versus the smoking one. So we have this for the left plot is for non-smoke and the right plot is for smoker. Okay, so you can also use C-bound, you see, to generate this kind of comparison and the categorizations plotting. Okay, and this shows, okay, the tip percentage and versus the day, is it? But it's a comparison between the two different groups. So that's why we say, okay, C-bound plotting is quite useful. And to achieve this, you can call factor plotting. Okay, factor plot method. And as usual, you select X and Y axis. And the column is regarding smoke. And here, what is the column? It's not about the data column. Okay, so here the column is regarding the plotting column. So the plotting column is regarding smoking and non-smoking. Is it is that it can group the data? Is it? And the hue. Okay, what does the hue mean? It's the hue. It's going to differentiate like the dinner or lunch. Okay, the different time. So over here, if you take a look of plotting, we have two different color. We have blue color and we have the orange color, is it? So there's two different color. And if we take a look at the legend part, it shows, okay, it's based on time, is it? So how do we get that? It's you specify the hue, okay? So that hue can further help you do kind of like the grouping, is it? So we have the grouping by smoking, and we also use the color difference to show the grouping between like the dinner and the lunch, okay? So this is about the factor plot, the first example. And the second factor plot example, over here, if you take a look, compare with the previous one, it also specifies row, not just a column, okay? So here, if we take a look at the output, we will see we have two rows of plotting versus the single one of the previous one. So the first row is regarding dinner. And the second row, the time is regarding lunch. It's all regarding lunch. And for the column, then you have non-smoker and the smoker difference. So that's what over here row and the column means. So kind of like for your plot, you can do grouping, is it? And using the plots row and the column to do some further separation, okay? And this time for our plotting, and you specify the type is bar, okay, the bar, and the data, you specify the data source. So it gives us the bar plotting, and as usually the vertical line represents the 95% confidence interval, okay. So over here it just shows, and you can do further grouping with not just the column, but also with row, okay, specify. And then the next one, what it shows is, it just shows the kind is not a bar, okay? This time it's specified as box, okay? So what this box mean, if we take a look at the output result, yeah, it's not a bar, it's a box, each of it. So what does this mean, okay? So the middle vertical line over here, then it's represent the 50%. So it basically represents the median value, okay? And the right line, vertical line of the box, it represents the 75% tile, okay? And the left line, this left vertical box line, it represents 25% tile, okay? So the box basically represents the distribution between 25% tile to 75% tile. And the leftmost vertical line represents the minimum, and the rightmost represents the maximum, okay? And we also have outliers here, okay? So that's outliers shown as a diamond dots. So this is the other type with the box, not the bar, okay? So with Seibang for factor plot, you can also specify the box illustration. Okay, so basically that's all for the remaining part of our plotting. So the second very important package that we learned today